In the next part of lesson 2.5, we're going to look at more than one data set at the same time instead of just one data set and the z-scores of values in that one data set. So first we'll look at the introduction problem where 10 American households were surveyed and asked how many TVs they have in their house. The results are here. There's the 10 values. And we want to find the z-score of the number of televisions in your house. Right, so first we need to look at these 10 data values and put them into the calculator to find the mean and the standard deviation. Right, so we find that this is a sample, so the mean of this sample is 2.9. And the standard deviation of the sample is, well, it rounds to 1.2. So if we want to see how many televisions are in your house, or what the z-score is of the number of televisions in your house, is, let's see here, I'll find x equals 3. So I'll use 3 as my data value. So the z-score of 3 TVs in one house. So using the z-score calculation, and using our approximations of the population mean and standard deviation with our sample of 10 TVs, I'll substitute 3 in for x, 2.9 in for the mean, and 1.2 for the standard deviation, and that gives me a z-score of 0.08. Alright, so 3 TVs is just slightly above the mean. Now, depending on how many TVs you have, here is the calculations for 1 to 5 TVs in the household. And we can see between 1 and 5 TVs are all within 2 standard deviations of the mean. So that's all very usual. In our first example with the new problems where we're looking at 2 data sets at the same time, we're going to compare an SAT score to an ACT score. Right, so scores on the SAT have a mean of 1518. Right, I'm going to highlight that. We have a mean of 1518 and a standard deviation of 325. Scores on the ACT have a mean of 21.1 and a standard deviation of 4.8. So we're going to find out which is relatively better, a score of 2100 on the SAT or 29 on the ACT. The easiest way to get started on the problem from here is to create a table with our data values, or the values that they give us in the problem. So we have the SAT and we have the ACT. So looking back at the SAT data, we have a mean of 1518. So our mean is 1518. Our standard deviation is 325. And coming down to the end, we're looking at a score of 2100. Then the ACTs, we're looking at a mean of 21.1, a standard deviation of 4.8, and a score of 29. Alright, so in part A, we're finding the z-score on the SATs, so we're substituting in 2100 minus 1518 all divided by 325, and that z-score comes out to 1.79. Well, for the z-score on the SAT, again we'll go to our z-score formula and substitute in our value, which is a 29, subtract the mean of 21.1, divide by the standard deviation. We end up with a z-score of 1.65. Right? Now, looking at this, we see that the z-score for the SAT is greater. So that means the score of 2100 on the SAT is further above the mean than a score of 29 on the ACT, which is only 1.65 standard deviations above the mean. So here is how I would write my answer of which score is relatively better. A score of 2100 on the SAT is relatively better than a 29 on the ACT because it is more standard deviations above the mean. Okay? When we are writing our responses to a question like this, we want to state something about the standard deviations and mention the mean. In example 2, we're looking at the mean home value in Williamsport, which is $114,500 with a standard deviation of $10,000. So you find a well-kept 3-bedroom, 2-bathroom house that is 1,600 square feet for $139,900. So let's find the z-score of this list price. Right? So the mean is 114,500. The standard deviation is 10,000, and our data value is right here. So let's use our z-score formula, substitute in our values. We see that this z-score is 2.54. Now in part B, we're asked how would the z-score influence your offer to purchase the home? Okay. Here's how I would answer that. I would say the asking price is unusually high, so the buyer should make a low offer closer to the mean. So the asking price is unusually high because it's more than 2 standard deviations above the mean. It has a z-score of 2.54. In the last example, we were going to compare property values in Williamsport with property values in New York City. So suppose you purchased the home in Williamsport for $132,000. You have a friend who just purchased a property in New York City with 2 bedrooms and 1 bathroom that is 1,150 square feet for $463,000. She claims that she got a great deal since the asking price was over $475,000. Who got the better deal compared to other homes in the area? Now here we have a small table already organized with the mean and standard deviation in Williamsport and New York City. So I'm going to just add a little bit to the table. I'm going to add the home values that we're looking at. So that'll be our X. For Williamsport it is 132,000, and for New York it is 463,000. Right? So now we can find the z-score of these two homes. Right, for Williamsport and for New York City. Alright, so for Williamsport, setting up the z-score formula, we have 132,000 minus 114,500, all divided by the standard deviation of 10,000. This gives us a z-score of 1.75. Right, so it's still above the mean, but it's not unusual. Right? It's 1.75 standard deviations above the mean, so it's still kind of high though. For New York City home, we have z equals x minus mu divided by standard deviation again. So we substitute 463,000 minus the mean of 459,000, divide by the standard deviation of 35,000, and we have a z-score of 0.11. So to answer the question, we would say that the friend in New York City got the better deal because she paid less standard deviations above the mean, but she still paid more than the mean. All right.